Let me introduce Lauren, who is the Distinguished Professor of English and Comparative Literature at Rutgers University. She's also the editor of Critical AI and chair of the Critical AI at Rutgers program, as well as a faculty affiliate at the Center for Cultural Analysis, the Rutgers British Studies Center, and the Rutgers Center for Cognitive Science. At Rutgers, she served as Associate Chair of English and a member of the Executive Committee for Graduate Studies. She has pioneered the formation of an emerging interdisciplinary field of critical AI studies and the teaching of critical AI literacies, areas in which she's received a National Endowment for the Humanities International Grant for a project called Unboxing AI with collaborators from Australian National University, and a National Endowment for Humanities grant for Design Justice AI Labs, a creation of a shared digital infrastructure for students and community-centered teaching about research on generative AI. So please, Lauren.
Thank you so much for that wonderful introduction, and it's such a great honor to be here. So I have this issue going on with my HP laptop that it's sometimes the keyboard freezes. So I'm not going to show you my PowerPoint right away. I'm in the process of rebooting. It will ultimately boot, and then you'll get to look at some nice pictures. But for the moment, what you get is me. We know that the best performing chatbots.
Is this better? Yes. Okay. I'm always under the impression that I project really well, but we know that the best performing chatbots, such as ChatGPT or Claude, are built on large language models, trained through generative pre-trained transformers, which are optimized for predicting the probable. They are, in the memorable words of Emily Bender, Timnit Gebru, Margaret Mitchell, and other colleagues, stochastic parrots, or as I prefer to call them, since parrots are actually very smart animals, probabilistic mimics. In this, I concur with Yann LeCun, Meta's chief AI scientist, about which you've heard, who has pointed out that chatbots lack the intelligence of cats. And I just want to say, I did not use ChatGPT in the writing of this paper, but my cat did help me. Although a host of helpful workarounds, including the substantial use of human reinforcement provided by very low-paid workers, annotating problematic responses at an industrial pace, has been enlisted to improve these models. And I want to say that one of the things that I find is a little bit sad about discussions like today, even though in so many ways it's been tremendous, is that I am now the first person to mention the human workers that are, you know, that before ChatGPT was released, GPT-3, the model on which it was built, was wrong more than 50% of the time. So human workers had to annotate that data in order for there to be extra layers that would train the model to be more like what the humans preferred. So we're dealing with statistics all the way down, but also with human workers enlisted to make sure that the probability is greater that the humans will get what they want. And as Yoshua Bengio just said, that they've been trained to please us, and they try very, very hard to do that. So in spite of all those other workarounds, and there are more things going on now, things like retrieval augmented generation and so forth, two intractable problems remain, at least from a textual output. Bot-generated language is formulaic, and one of the things I wanted to show you on my slide was some outputs that I had done recently. As the rhetorician Liz Losh puts it, They generate simplistic vagaries that lack a strong ability to engage with the meaning-making activities of real-world audiences. They don't talk like I am right now. At their best, they talk like Wikipedia pages, which is Wikipedia made them possible. They can, if I were speaking in a different language, they might help me to improve my grammar and syntax, but they're not going to be able to sound like a really, really strong writer without help from a really strong writer. Even the latest models continue to confabulate at a terrific pace. GPT 4.5, according to OpenAI, confabulates about a third of the time. People using the model will help it to get better. They'll vote answers up or down. They cannot trace their outputs to particular sources of information. Why is that? Well, because they're now re-articulated. It's not reaching a database. The reason why we understand more about these models than you might think is that we know that they're operating on a compressed mathematical representation of their training data. It comes pretty close to memorization. But because there's so many computations involved and so many parameters, a GPT cannot say with any reliability, this is where I got the information from. It can only make a guess or answer that question in an unmeaningful way, as if it were having a conversation about sources. It cannot. And when you see something footnote-like on one of these systems, what you're getting is what I call annotation theater. A different system, usually retrieval augmented generation, is making a guess about what might be a good source for that synthesized output, kind of like a student who already knows what they want to say and then looks for a source to back it up. And often, Perplexity AI does this all the time. The actual source is occluded. So it can be something that a journalist wrote. That source is occluded entirely, even though that was the source that made the information possible. Moreover, none of these things should surprise us. A lot of the discussion in AI hype is dealt in terms of shock and awe. And I understand why. I completely understand why. I am not telling you that we have nothing to worry about or nothing to be impressed by. That neither is my message. But what I am telling you is that we know a lot about how these models work. And the reason that we should not be surprised, and this is where you are going to get a slide of the journal that I edit, Critical AI, including the article where you could read this. The reason that you should not be surprised is that these systems, chatbots like ChatGPT, or supposedly strong research tools like Notebook LM, they weren't developed as robust frameworks for human-like communication or information retrieval. They occurred through the steady advance of statistical proxies for predicting the plausibility of automated transcriptions, like voice recognition systems, and translations, like Google Translate. That's how they developed, through the increasingly strong ability to probabilistically score what would be a good output. So when you understand what that means, it puts a lot of things into perspective, because as anyone who has looked at a bell curve knows, it is a probable prediction tool, and that can be super powerful. But what it lacks is a sense of anything that is not in its training data, anything that didn't occur in the past, and what it lacks in the case of an operationalized generative model is the likelihood of producing anything from the tails of the bell curve or the edge cases, which is why I am constantly using vocabulary that, that Google thinks is wrong. Because unlike me, a professor of Victorian literature originally, I use words such as, which is the word that it always corrects, importunate. I say, I am sorry to be so importunate to a reviewer who was supposed to give me something 3 weeks ago, and it thinks that I must mean I'm sorry to be so impatient, which of course means something different than importunate. So think about that bell curve construct, because that's essentially what we're dealing with these tools. So the rise of these powerful models for probabilistic scoring of text arose from within and exacerbated an increasing faith in the wonders of scale, except that we are now running out of good data as the internet increasingly becomes full of AI slop, and as people who write really good and important things are reluctant to put their work on the internet as training, uncredited, uncompensated, unconsented training. So in a sense, and again, I had a slide for you, we're in a situation where that aspect of the improvement, which involves making models bigger by an order of magnitude times 10 in order to make them incrementally less likely to confabulate, that version of how to make the models better, which was so successful from GPT-2 to 3 to 4, is over. Some people think you can get it through synthetic data, but models trained on outputs from other models have been shown to tend to collapse because they become more and more full of probable content to the point where they can no longer operate in a functional way on anything that is even slightly improbable. That paper, again, no slide, is Shumilov and colleagues. It was just published in Nature after being on archive for a while, but I can tell you more about it later. So, you know, that idea about scale, it comes from a mentality that I call data positivism. One of the archetypes of this was the well-known Norvig and colleagues paper of 2008, The Unreasonable Effectiveness of Data, which basically is making the argument that you don't need to ask hypothetical questions. You simply see what's in the data. You don't need to be an expert on something. You don't need to consult experts on something. You look for the correlations in the data, which again is really powerful as a tool, but won't tell you anything that isn't in the data. And of course, the data that large language models have been trained on is the internet. And while the tendency is to think that the internet is fabulously, universalizing and total, it is mainly English language spoken stuff. And it mainly excludes languages spoken by billions of people and their cultural opinions. And it overrepresents the opinions of everybody else. And that's one of the reasons that GPT-3 was wrong more than 50% of the time. It was getting a lot of its information from sites like Reddit. I heard somebody say, I don't know if it's true, that Reddit is about 8% of GPT-3's training data. I have no way of validating that. So who knows, maybe a language model said it. So the idea is now that we're going to take these probabilistic mimics that have been reinforced by humans and that have various workarounds, and we're going to continue to mitigate their problems. And so long as we can mitigate, a certain amount of toxicities and falsehoods, it's okay for us to deploy them, even though it is well known and has been known since the 60s that humans are very susceptible to the deceptiveness of any system that appears to use sensible language. I agree with what Yeshua Bengio just said about chatbots persuading people of things. But let me tell you that the ELIZA chatbot from 1966, which was a very simple pattern matching system that pretended to be a psychoanalyst, persuaded people easily, right? It seems to be something reflexive about human behavior, that humans react to language in a very powerful way. For a very long time, they were the only beings that generated it. And we all know that we anthropomorphize our animals and plants and cars all the time. It's one of the things that we do that makes us kind of interesting creatures, right? We love to, and maybe that's part of the way that we were able to mature and give up our parents. We decided that there were living things everywhere, our dolls, who knows? There's a world of really interesting anthropology and cognitive science that is going to come out of the study of this. But humans can be easily fooled into believing that a system is intelligent, that it's more intelligent than them, that they should fall in love with it, that it is their dead grandmother. And lots of people are looking to cash in on this susceptibility. Although it's worth noting that it's a quite recent decision on the part of people to engineer systems like this. When Siri was introduced back in 2011, the engineering culture was against anything that would trigger the ELIZA effect. And so Siri was introduced in a way that made it clear that most of the intelligence was to do with program scripts and the ability to search the web, not with things like, oh, I'm so sorry I got that wrong. Let me look again for you. All of that sort of stuff, which is supposed to make us feel comfortable and trusting of systems like ChatGPT despite their problems. So this motive to anthropomorphize, it partly comes from the desire to market a killer application to expand and hopefully dominate a potentially trillion-dollar market for digital assistants in various forms. Another reason is the perception of what we're talking about today, that they are in a position to lead to something called artificial intelligence. And I'm going to skip over my various definitions of it because you've heard all about them, except to say that a lot of the people who are responsible for the architectures and the science behind this are what is sometimes called connectionists. And they are, for that reason, the most likely to believe that these architectures mimic the human brain. That's why they call them neural networks. They talk about the distributedness of the way that they work. And these people often believe, I'm sorry to call them these people. I mean, it sounds as if I'm being very dehumanizing, but such scientists will also tend to believe that the human brain works through statistics. But the truth is that there are all kinds of things we don't know about the human brain. It may well be statistical. There's no actual evidence for that. But the idea that we have reverse engineered the human brain in the form of a language model is completely unproved. And, on its face, it makes no sense because humans don't memorize the contents of the internet in order to learn things. humans are actually, at least consciously, quite bad at prediction. The reason that statistics was invented around 1600 was that humans are constantly, they get over optimistic. If they see too many connections, they start to get paranoid. So statistics had to be invented as a mathematical apparatus in order to do a better job of behaving toward the world in a probabilistic fashion. And now what we see is that we're getting a kind of narrow, several people have said this already, sense of what it means to be human, as if we are optimized for efficiency and productivity only. And that too is not, it's not completely new. Jeremy Bentham had the philosophic calculus. He believed that you could have the greatest happiness for the greatest number. There are numerous reasons why he would have been horrified by taking the idea to this level. He believed that that should be enacted socially through laws that incentivize good behavior. The person who gave utilitarian philosophy the oomph it needed after Bentham was John Stuart Mill. And if he's hearing this, he's been rolling in his grave for I don't know how long. This is absolutely not what Mill, who believed very strongly that people should be educated widely, should know. So the safety stuff, I'm skipping over a lot of things. I agree that it's very important. But I also agree that, and others have said this, that we need to be thinking now about the risks and harms that we already have, right? And slide that you should imagine for Margaret Mitchell and her colleagues' paper at Hugging Face, which basically says that we should not be allowing fully autonomous agents of any kind to be harnessed to LLMs. In fact, we shouldn't be building them at all. And though I agreed with a lot of the things that Yeshua Bengio was saying, the idea that it would be safer to train it as a scientist mentality rather than a make you happy mentality, I think that's actually a really bad idea. And if you don't want to hear it from me, please look at a paper by Lisa Messeri, Messeri, and MJ Crockett, which is all about the problems that arise when social scientists in particular start to think of language models as either scientists or scientific subjects. Basically, they end up thinking that they know all kinds of things that they don't know and understanding less. We know the actually existing harms of these models. They recapitulate biases and stereotypes. You have to imagine my slides that you can't see. They infringe on copyright protections. We have miserable artists and guitar players. We have Brian Eno telling us we're making mistakes. We have Nick Cave aghast. I mean, you know, this is the art world is just completely not in favor of being ripped off so that mediocre music can be made for cheap. And they surveil their users constantly. They leak our data. They can be hacked. They expend enormous amounts of energy, water, and investment. The so-called reasoning models expend even more water and energy. Because again, theater. So I believe his name is Noah Brown, OpenAI person who was one of the leads on the so-called reasoning model, asked point blank, what is it doing when it says it's thinking, when it talks to itself? Do you know that those things have anything to do with what it's actually doing? We don't know that. It's computing. It's doing more computation. One of the things that is not talked enough about in relation to these models is something called brute force. This means doing a massive amount of calculations so that you figure out every possibility. And what these O3 reasoning models are doing is doing more of that type of calculation, probably by brute forcing out several different iterations, different ways you can go, and then it's able to score the best one. So now I get to the sort of happier part of what I want to say, which is that my own research and grant-related activities are increasingly in the domain of higher education. I was slightly saddened to see Yashua Bengio think that language models are what we need in education, though I do think we need great digital assistants. What we don't need are digital tools that actually publicize themselves as reducing cognitive load. Cognitive load is a way of describing learning. People do not learn things that they don't do, including software engineers, as is now being discovered by people that are implementing coding tools. They're finding that they have to produce special guardrails because the teams have become very focused on who's the fastest and who can be the most efficient. They cannot explain why they've done what they've done because they haven't made those decisions. So at Rutgers, we have an NEH grant called Design Justice Labs. Our goal is to teach students about these systems the way that data scientists would learn about them, by teaching them critical AI literacies, by helping them to understand how the models work, and by having them probe the models through experiments of their own design in order to see what problems they're susceptible to. This is a win-win because employer wants a student who knows their way around some of these things. Student can say, I didn't write my papers with Claude 3.7. I probed it and here are my results, right? Much smarter. We're told by, to tell students the future jobs are going to go to the people who understand how to use AI. What we tell them is that the future jobs are going to go to the people who know what AI cannot do and what it can do. But let's face it, these are not hard models to use, right? I mean, their interfaces have been made very, very simple. These were key insights for our new NSF grant, Writing Education Through Design-Oriented AI, where we're going to do something shocking. We're going to ask students and writing instructors what kind of tools they would like to have. And if they have really good ideas, we're going to get money to build them. We actually think that it's a good idea to find out what people need. And instead of saying, I have this wonderful hammer, it surprises me every day, you've got a nail, we're going to say, tell me about your nail. Tell me about your pain points. What would you like a digital assistant for? What would you like your students to have it for? And we're going to start designing tools in that way. I think I'm going to stop because we want to have a discussion and you all look very, very tired. But I'm going to end by just mentioning something that I wanted to mention, which is that how many of you read Philip Dick? Okay, a few of you. So it's not one of his best stories. It is one of his earliest. What my students find pleasant about this is that it's not a new problem. It's not entirely new. Like most of Dick's fiction, it is dystopian. It's a 1953 story called The Variable Man. And it's about a man who comes from the past, 1913, into the future of 2036, and who breaks all the models because they can't predict what he will do. They have no data for him. So their models cease to function, which means they have to stop fighting the forever war that they've been in. And they notice that he knows how to fix things. And he does it with his hands. And what Dick is really intuitive about in this story is that intelligence is fully embodied. There are lots of people who are good with their hands, and that is how they figure out things. There are people who are good because they're very emotionally aware. There are people who are great with animals. There are people, we all know in our experience, we know that intelligence comes in many, many forms. The last thing I'll tell you about people versus machines, and by the way, I'm not anti-machines and I'm not anti-AI. I think machine intelligence can be very valuable. I think we should study it comparatively. Human intelligence, machine intelligence, two different things. Let's study them just the way we would study dog intelligence and human intelligence as different. Though, again, dogs are much smarter than ChatGPT. Let me tell you something that you're doing right now that ChatGPT cannot do. You are listening to me, or at least about half of you are, and as you do so, you are taking in what I'm saying. You're responding to it. You are feeling it. You're changing slight things about the way that you think about AI. This is, there are many words for it, but let's call it experience. You're processing it right now. Maybe you're going to, and notice I did use an anthropomorphized word. Or rather, I used the machinized word for an anthropomorphic act, that you're processing it. You're dealing with it. You're listening to it. You're analyzing it. A machine cannot do that in the moment. It will respond to an input as it's been instructed to by giving you the output that it predicts to be responsive to what you want. But it does not automatically become part of its model. Those inputs would need to be collected by the developers, and the model would either need to be fine-tuned with that data or perhaps retrained. These are pre-trained models, and if they constantly took in everything that every person who used them might say, it would knock off their statistical weights, right? Maybe the input is coming from a person who has a lot of untrue information about something, right? You could deal with that because hopefully if you knew about the subject, you would say, well, I'm not going to listen to that. That sounds kind of dumb. So we are in the moment right now. We are not operating in a fashion that is going to make the future depend on what happened in the past. We are thinking about the future from the vantage of the present, and we're building up what we know in order to think about the future. As we think about the future together, here's just one very simple thing I suggest. Let's stop using anthropomorphized words to describe these models. They are not thinking. They're not talking to themselves. Their reasoning is statistical inference. If you like that word, you can also call it abduction. And although these words have been conventional, words like experience and so forth, we don't have to use them. They were always understood by a previous generation of engineers to be proxies, mere proxies for what humans do. But the youngest generation of engineers needs to learn that anew, and in circumstances where there's a lot of hype to the contrary. So let's just choose our words carefully, and thank you.